So today's going to be binary notation. And there's different types of binary notation, but we mostly use different sorts of binary, such as bits, bytes, and which are used to measure amounts of binary, and denary / decimal, and hexadecimal. So binary is the mathematical in digital electronics is either represented in base 2, which is either a 0 or a 1. And we use this because computers use electricity and voltage, which it can either be on or off. It can't be to anything else. So it's represented as 0 is off and 1 is on. And binary figures are normally represented in different ways, but the most common one is an 8-bit binary, which is represented below as like that. And a bit is just short for binary digit, and it's just the smallest unit, so we use it. It usually represents just a 1 or a 0. That one counts as a bit. Bytes are not a central memory unit and they usually make up a string of at least 8 bits. So for example, this number right here, the 00101101, this is a 1 byte as it consists of 8 bits. So denary / decimal is more referred to as decimal, as it's base 10, and it's the standard number systems from 0 to 9. So to represent all numbers. So how to convert is you have your example here, this number here, and then each binary bit has a placeholder. So you see that we start on the 0th placeholder and go to the 7th. And because it works in base 10, we normally do it so that they correspond. So 1, 2, 4, 8, 16, 32, 64, 128. And then what we do is when it's on, we write that down. So because there's 2 zeros on 120 and 64, we put 2 zeros. Or 1 on 32, we put a 32 down. 0 on 16, we put a 0 down. And so on. So we said 32, 8, and 4. And if we add all those and 1, and if we add all those up, this is how we find our denary. So this is binary to denary. Hexadecimal is the numeral system, often short to hex. It's made up of 16 symbols, it's base 16, and we use this because it's easier to represent every byte. Rather than using 8 digits, we can just use 2. And how to read it is pretty straightforward as well. So we have each up to 9, 1 to 9 is just a normal denary, but from 10 to 15 we use A to F. So if we have a number such as here, this one right here, so we have this, so we convert it, first we split it into 4, it's meant to say nibbles. So we have the 4, we cut it in half, we get our 2 things. Then we convert this using binary. So because it's only 4, we have 8, 4, 2, and 1. And so then we go, so it's 9 for 1 and 1, because 8 plus 1. And for this, you have 8 plus 4 plus 2, which is 14. And 9 stays the same because it just corresponds to the 9. But because 14 is over 10, it becomes an E. So to read it, it's 9E.